The next thing we're going to look at is coordinate geometry, or I suppose as it's more correctly called, Cartesian geometry, named after a famous French philosopher and mathematician, René Descartes. He was the first person to come up with the idea of coordinates as a way of describing a position. So hence this whole field of geometry is named after him, Cartesian geometry. So a couple of formulas which I hope you remember from previous years. Distance formula, which is basically Pythagoras' theorem. When you think about it, you want to find distance between 2 points on the number plane. What you're really doing is finding the length of the hypotenuse. And one of the edges of the triangle would be the difference in the x values. And one of the edges on a triangle would be the difference in the y values. And so that's really all the distance formula is, Pythagoras' theorem. Square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So here we go, simple little example. 1, 3 and 3, 5. Sub it in. So the actual order doesn't matter, as long as you say the difference in the x values and the difference in the y values. So I get 2 squared and 4 squared, and that gives me 2 root 5. Distance formula, hypotenuse. The other formula that we often see and use in coordinate geometry, midpoint, which really is just finding the average of 2 points, and that's why we add the coordinates together and divide by 2, because that's how you find the average of 2 numbers, of course. And so if we had to find the midpoint of 3, 4 and minus 2, 1, add the values together, divide by 2, and there's our midpoint. So I say 2 formulas which hopefully we are familiar with. Now, an extension to the midpoint idea that we look at in extension 1 is what we call division of an interval. Okay? Midpoint basically divides the interval up evenly in the ratio 1 to 1, if you like. In extension 1, we look at ones where we divide them in different ratios. So let's see what we're talking about. Here's an interval xy. Now, if I plot a point, there it is, A, somewhere in between x and y, and I could say A divides xy internally, because it's in between x and y. So we say it's internally divided in the ratio m to n. So that means from A to x is m parts, and from A to y is n parts. So the naming of the line and the ratio is important. It must match, so we get the correct measurements. If I was to call the line yx, then I would say it's dividing it in the ratio n to m, because from A to y is n, from A to x is m. So it needs to match up. That's what we call an internal division. Now, an external division is when that point actually, it's on the same line. If we were to extend the line, or produce the line as more correctly called, and A is outside of x and y, then we say it's externally in the ratio. And again, if I say m to m, that means A to x is m parts, and A to y is n parts. So let's have a look at some different types of questions we could get on this. Look at all different past HSC questions. Here's one from 2003, where it simply says, find the point P that divides in the ratio 1 to 3. Now, there is a formula for this. Don't ask me what it is, because I don't know. This is how I do it. Okay. I'll write down the endpoints of the interval in the same order as they're mentioned. So in this case, I'll write down minus 3, 4, and then 5, 6, because that's the order they're mentioned in the question. Then I'm going to write down the ratio underneath it. So the ratio is 1 to 3. And then I draw a cross. And you can choose any colour you like. I chose red and blue. Okay, and this is how I set up my answer. I draw a set of parentheses with 2 vinculums. To get the denominator, I add the 2 numbers together that are in the ratio. 3 and 1. Yes, it wasn't a trick question. 4. So now on the bottom of the fraction goes 4. And to work out the number that goes in the numerator, I multiply along the crosses. And to get the x values, I use the x values, strangely enough. And to get the y value, I use the y values. So multiplying along the cross, I would go 3 times negative 3 plus 1 times 5. And that gets me the x value. And to get the y value, 3 times 4 and 1 times 6. And that works out to be negative 4 and 18. And that simplifies down. And there's my answer, negative 1, 9 on 2. Okay. So that's how I would do an internal division. So I don't bother with the formula. I just write the coordinates down, write the ratio down, draw myself across and go, bang, there's the answer. External division, how do I do that one? Well, basically the same way. So let's write down the points. There's A and B. The ratio is 5 to 2, but with an external division, the ratio is negative. So I write down negative 5 to 2. Now, as a ratio is the same as a fraction, it doesn't matter where the negative sign is. You can put it on the top of the fraction, you can put it on the bottom. So I can make it negative 5, 2, I can make it 5 to negative 2, doesn't matter. It's up to you. Draw them across, and let's work out our answer. Bottom of the fraction, add the ratio together. Negative 5 and 2 is negative 3. To get the top of the fraction, multiply along the crosses. So for the x value, 2 times 3, negative 5 times 9. To get the y values, 2 times negative 1, negative 5 times 2. And that simplifies down to be, there it is, 13.4. I just find that a lot easier than trying to remember a formula. So I just think, oh, well, there's my picture. Bang, that's what I've got to do. Well, here's another type of question they might ask, a little variation on the formula, where this time I have to find the endpoints. So they've given me the answer. The answer is 1, 4. And they've given me one endpoint of the interval, negative 1, 8. I have to find the other one, x, y. And it's an internal in the ratio 2 to 3. So how will I do it? Well, I'm going to do it exactly the same. I'm going to write down the 2 points, just I don't know the second point. The ratio is 2 to 3. Drawing my crosses. But I know what the answer is going to be. So I can create a couple of equations. So for the x value, I know the answer is 1. And in order to get 1, I would have said, oh, well, bottom of the fraction, add the two numbers together. That's 5. To get the top of the fraction, multiply along the crosses. 3 times negative 1, 2 times x, what I'm trying to find. And there's an equation to solve. And so let's play around with that one. Multiply by 5, move things around. Okay, I know the x coordinate is 4. Now I'll go do the same thing with the y coordinate. So this time I know the answer is 4. Bottom of the fraction is 5 again, of course. 3 times 8 and 2 times, well, y is what I'm trying to find. Play around with that little equation. And I get negative 2. And so there's my answer. That other endpoint must have been 4, negative 2. That's one way I could approach that. Another way I could approach that same problem. Okay. If I just draw myself a little picture, A, B. I'm trying to find the coordinates of B. But P divides AB internally in the ratio 2 to 3. So P is somewhere in the middle in the ratio 2 to 3. I could change this question because A and P are the 2 points that I know. I want to find B. Well, B will divide AP externally. So I could change the question to be B divides AP externally in the ratio, well, B to A, well, that's 3 plus 2, so 5 parts all up. And B to P is 3 parts all up. And then I'll just do it like I did the other ones. Let's find the point that divides minus 1, 8 and 1, 4 externally. So I'll make one of the ratio numbers negative. In the ratio 5 to 3. Okay. Bottom of the fraction, negative 2. Top of the fraction for the x's, 3 times negative 1, negative 5 times 1. Y values, 3 times 8, negative 5 times 4. And, surprise, surprise, we get the same answer. That's another way of thinking about that question. I could change the question into something I'm familiar with. Ooh, palindromic year, 1991. find the actual ratio. So this time, they've given me the answer minus 3/8. They've given me the two endpoints, but they haven't told me what the ratio is. So they've told me one of the numbers. They've said it's the ratio k to 1. I've got to find out what k is. All right, so I'll do the same as I normally do. There's the two endpoints. The ratio is minus k to 1 because they said externally. Put in the crosses. And I know what the answer is. So let's have a look at the x value. It doesn't actually matter. I could do the x value or I could do the y value because the answer for k has got to be the same in both. So I did the x values. So bottom of the fraction, minus k plus 1. Top of the fraction, 1 times 6. And then minus k times 0. And I know the answer for that. The x values is minus 3. Playing around with that equation, 3k minus 3 is 6. K ends up being 3. So P divides AB externally in the ratio 3 to 1. 3 to 1. Okay. So 5A, it is in the first book, I believe. Some bit of coordinate geometry, Cartesian geometry, whatever you prefer to call it.